so people are on the phone. And so if you have a question, please raise your hand. We'll pass you the microphone. It's mostly for the people on the phone so that they can hear the question. And then Carl is also mic so they can hear the answer. And so very much as it was last year, it's just a Q&A session. So this is your opportunity to ask Carl whatever you'd like. And we do have a hard stop at 4 o'clock, so we have about an hour. So without further ado, ask your first question.
Hey, good afternoon, everybody.
Charles Brodowski here. During the keynote, you talked a lot about web-based computing, but you didn't really give any details how that would be implemented in AutoCAD and other software.
So during the presentation, so there were two indications that were very literal, and then let me talk about cloud computing in general. So the two implications that were pretty clear was, first one is, you see an example of it with Project Twitch that I talked about. You know, and what Project Twitch is, it's running computers in a virtualized data center. And what you deliver is compressed video. And so in one direction comes compressed video, the other direction goes things like keyboard and mouse clicks. And there's a pretty good description of it on the website, but really what you're doing at that point is you're taking classic desktop applications, running them in a data center, often in a virtualized way, and then you're just delivering the video to the user. And so what the user is experiencing is the exact same desktop application that they would have experienced, because it is actually the same code. One way I think about it, it's a really, really long monitor cable. Okay, so that's one example of how to do it. And I think there's some virtue, you know, we can talk about the pros and cons. Second one we showed was that one where there was a side-by-side of two people co-editing, editing simultaneously. And what you were looking at there was something entirely different, probably the other end of the spectrum, in which a native application, you know, a written-for-web application is actually managing data on a server, running on a server, and you have multiple people accessing it, and the client for them is just a browser. So no client, again, running in the data center, but the software is designed from the ground up to be deployed that way. As opposed to in the first example we were talking about, examples where the software really is classic desktop software, you know, a Windows executable, a Macintosh executable, sitting there running and you're piping the video. There were several other examples of, you know, web-based computing, things like Project Dragonfly, which was that home decorating application, again, is really very similar to the AutoCAD co-editing one, in which it's a native application written for the web, deployed in a data center on servers. And so I think there's a variety there. And then the non-explicit ones, but you know, certainly I referenced it and Jeff did all throughout, is this idea that one of the places that's clearly an opportunity for all of us is to use the computing power that comes from a web-based model for taking advantage of any of those tasks that are compute intensive, peak demand loading. And that can be anything from rendering, you know, any kind of animation, and certainly all kinds of analysis and simulation. Wouldn't it be great if instead of running a mold flow calculation that would have taken 24 hours, what if I could run 100 mold flow applications and the whole thing takes an hour? And that's the possibility you have, not only of doing it simultaneously, but you get to do multiple runs at once. And I you know, as you could hear from my talk this morning, I think it's a big deal. I think we will be all running variants of this. You know, if you look out 3 to 5 years, most software will be deployed in ways that are very similar to this.
Defender from 10 Links. Carl, I saw your gratuitous iPhone shot.
Here's my gratuitous iPhone.
And also, I think Autodesk got a lot of mileage out of showing Apple products and the iPhone several times during the keynote. But you also gave a teaser. You said there'd be a lot of stuff ported. I don't remember the exact words. A lot of things being, a lot of applications being ported to the Apple I wonder if you could give any more about that, or specifically, I think my question is, will AutoCAD be ported to?
So I won't give you any more. It's a good question, Rupinder. You get credit for that. I won't say anything more specifically about specific things we're going to port or not port. But I think, it was kind of funny standing up there and saying that there was a resurgence in the Mac. If you think about it, for many people, it never went away. Certainly amongst some of our diehards or amongst the Apple loyalists, it never went away. But clearly its market share is rising, amongst our type of customer. It's clearly high. There's a high use already. We see a phenomenal amount of use of Apple hardware running Windows for all the obvious reasons. And I think many people would like a more native way to do it. So we have a handful of products. Interestingly enough, the products that we've led with are mostly our media and entertainment products, so there's more there than anywhere else. But we're looking at them all, and I think customers have been asking for it for a long time. For those of you, and there's a couple in the room, I won't name names, have been around long enough. I mean, there was a time when AutoCAD did run on the Mac, and we stopped it running on the Mac because there wasn't a big enough customer base. And so I think you'll see a number of things. And, trying to hint at some of the motivation was not just making Apple customers happy, was this idea as you go to look at more flexible ways to deploy your technology, the natural step you take in getting rid of all the stuff that's tied to a single platform allows you to run on multiple platforms. It allows you to run on the web. It allows you to run on mobile devices. So there's a lot of nice stuff just from a software engineering point of view that you need to do that allows you to run on other platforms. Mr. Day.
Hi, Carl. You've got Project Cooper, which is kind of LT of LT. You've got LT, you've got AutoCAD. You spent a lot of time telling everyone that AutoCAD's 2D, but in reality it's now a pretty strong 3D play. What's the positioning going to be with LT of LT plus AutoCAD? It's a bit confusing.
The question is certainly...
is there a space for... is AutoCAD LT really now the new AutoCAD? And
go ahead.
Yeah, that kind of...
Okay, so let me talk about a couple of things. So first of all, you're correct. AutoCAD is very 3D. It has, the first 3D showed up, about when we stopped making it for the Mac.
Yeah.
AutoCAD has had 3D for a long time. Over the last few years, it's got a tremendous amount of 3D in it. And most people would have no idea. I wanted to do this thing for Mainstage, which was hold up different designs and then ask people to vote with like one of those silly boxes, which piece of software actually made it. Because the amount of software that I've seen recently that was done in AutoCAD, I would not in a million years have thought it was done in AutoCAD. Because of kind of our mental positioning, that AutoCAD is there for doing drawing, documentation, and that when you look at the two things, kind of the surface modeling on the side of it, some of the solid modeling, and then the picture that you saw that Jeff showed of the point clouds, working inside an AutoCAD environment, all that talks to it. It is really 3D. I think the real differentiation between AutoCAD, and I think this, you can generalize this to products that come from from companies other than Autodesk, is AutoCAD is very much a 2D and 3D product. The other products that we talk about a lot, generally speaking, have some kind of underlying model. So the conceptual framework for it is there's a model of something underneath it that it's representing some other object. So, in the case of Inventor, you're building a physical, mechanical object, and there's a natural kind of object model that underlies it that talks about mechanical parts. In Revit, you're trying to model a building. Often in Maya and Max, you're trying to do things like